We're going to take a tennis ball and we're going to throw it straight up at the damning velocity of 25 meters per second.
Yeah, okay.
Okay? So we're assuming that the ground is the reference point. Okay, so the point that I let go of it is where we're going to judge everything from.
You tried to bully me saying that I chose a wrong number.
Huh?
Yeah,
It's a great number.
me.
It's a great number. It's a perfect number.
What's wrong with 25?
Nothing.
Nothing.
Exactly.
It's a perfect
and you tried to
square.
bully
Yeah, I
me for
completely
it.
forgot it was a perfect square.
Yeah.
You tried to make the argument. It's like it's not a perfect square.
Yeah, if you picked like 23 or something, like, that would have been gross.
Yeah.
I did math.
Oh, the
reasons.
23 is my
I
lucky
did
number.
math reasons.
Really?
That's why it's-
Yeah.
Would have chose
Okay.
27.
It's on my math yesterday.
That would have been worse.
So-
Actually, no, that could be divided. 29.
When I let go of it, at the very instant that I let go of it, what's the only type of energy that it has?
Kinetic.
Kinetic. So this is the reverse of what we
The
just
moment you let
did,
go.
right?
No,
So
there's no distance
if you look at
between it and the
a
reference
chart, and you have UG, and you have KT, and you have the sum. So now, if I'm standing on top of a mountain and throw it and it falls, obviously I have to take that into account. But I'm just saying I'm going to go from here and then have it come back down. That's it. Okay? So I'm establishing the ground as my height of 0. Okay? That's 0. That's my reference point. So how much UG do I have?
None.
None. I have OJ, right? I have no UG. Cool. Do I have enough information to calculate my kinetic energy?
Yeah.
Do you have,
No.
wait, yeah, you get 1/2 mv squared.
I have 1/2 mv
Oh,
squared. Check my math,
Oh,
but
yeah, we have the
more.
velocity.
that's going to be 1/2 my mass of 0.1 kilograms times my velocity squared. So, calculators please. 25 squared and then times 0.1 times 0.5.
31.3.
31.3? Everybody cool with that? Because
Yeah,
if that
yes.
number is wrong, if that number is wrong, everything is wrong. So we're solid at 31.3.
Yeah, 31.25.
Yeah.
Depends on how many sig figs you want.
3 is cool. So now I got 31.3 joules. Cool. So that's the entire amount of energy that can ever exist within this system. So, knowing that information, that's when I throw it. So, using that information, can I figure out how high the ball is going to go from an energy perspective?
Yeah.
Tell me.
Yes.
Why?
Because energy can't just disappear, so it's got to have, at some point, an UG of 31.3.
Yeah. So at some point, it's going to have an UG of 31.3 joules. Now, this is where it kind of goes full circle. What's the velocity at the top?
0.
0, because it's going to
Change direction.
change direction.
Slow down, stop, change direction. Accelerate.
So, because my sum still has to add up to 31.3 joules.
Yeah.
So knowing that my UG is 31.3 joules, how can, from an energy perspective, how can I find the height?
V squared equals V naught.
No.
I don't
From an energy
Oh,
perspective,
couldn't you just do MGH?
what does UG equal?
MGH?
MGH. Oh, and we know mass, we know gravity. We can solve for height because we know UG. Yeah.
Yes.
So UG over mg equals height.
Yes.
That makes sense. And it's
True.
way better than the thing that I said.
So 31.3
Yes, much
joules
better.
divided by 0.1 kilograms times G, otherwise known as 0.98. And what do you get?
31.8.
31, what?
31.9. 9.
Yeah, can we
8,
just not
8.
read? Okay.
8, 8. I don't know how to
that
round.
was judging.
Yeah, Judge Sean, be quiet.
Whoa now.
He's already judged like
Less
3
than
different people within
3.13.
5 minutes.
Yeah,
Okay,
yeah. You don't get to cast any stones there, Mr. Less
Yeah.
than 3.13.
Hey, everybody jumped
At least
on
I-
that bandwagon.
I know.
No, I didn't. I jumped on
You
a train.
did too. You certainly did.
I never said I was on the C train. I said I was in the station.
Hey,
I jumped on a
you-
train of my own independent
Yeah,
thought.
you
Was it the
tried
wrong
to
train?
bandwagon
Yes,
and
but it was
yes.
the closest
But it
train.
was your train.
It was my train.
I'll give you that.
It was your personal, completely wrong train.
Okay,
Yeah.
Yeah,
Now-
this was also really.
so that was at the top.
More wrong.
Preston, pick a number between 10 and 20.
19.
19.
Oh my god.
Hey,
Get out.
The
Choose a
wrath.
different number,
You
Preston.
cannot be talking about my
Yeah,
number.
get out.
Choose a different number.
No, no,
16,
no,
which is a perfect
no,
square.
that's Preston numbers.
Oh,
So the ball has a maximum height of 31 meters. So what I want to know was when that ball is 19 meters above the ground, I want to know how much UG it has, how much kinetic energy it has, and the velocity.
Well, UG equals mass gravity height. We know the height, so we can solve for UG. We know the total amount of energy, so we can just subtract from the total amount to get kinetic,
Okay,
right?
yeah, I like it.
good
I
stuff
like it.
coming.
So let's start with the UG. So
I
that's
learned
0.1
something.
kilograms
Over a full lecture.
times G times 19. What do you get?
18.6.
18.6. Now, does it make any difference if that ball is on the way up or on the way down when it crosses that 19 meter mark? Is that going to make any difference in terms of that calculation?
No,
Doesn't matter.
because we're not doing the bounce thing.
We're not doing the,
It's
we are so not doing the bouncing. So, if I just hold it at 19 meters, if it's going up and crosses 19 meters, if it's falling down and it crosses 19 meters, doesn't matter. What's the only thing that determines the potential energy at the 19 meter mark?
height,
Height, mass, and
gravity.
whether it's moving or not does not matter. Not part of the story. Okay? Now, so now I've got 18.6 joules. So how much kinetic energy is it going to have?
12.7.
12 points.
12.7?
Well, yeah, I got.
What? Wait.
Full value, so it'd be
Doesn't
12.6.
add up though.
It'd be 12.6 for full values.
Yeah.
'Cause-
But everything has to add up to
So
31.3.
it would be
Yeah.
total-
yeah,
Yeah.
Yeah?
the original full value of 31.3 was.
Okay, so we got 12.7
Yeah, push
joules.
rows down. After you.
Now I need to figure out how fast it's going. What does my answer have to be less than?
I don't know. 25.
Yes, it has to be less than 25. Otherwise, I have
Gained energy.
I've created
magically.
energy, which would be cool. Don't get me wrong.
You
Okay?
bounce it and
Solve
you
the energy crisis. No, throw a tennis ball up in the air. Really, that's all we have to do.
It'll
Okay.
infinitely accelerate.
So, according to the Preston equation, 2 times my kinetic energy divided by mass gets me my velocity. What are you going to do wrong when you work this?
Forget to square root.
You're going to forget to take the square root of this number. Okay? Promise
I'm gonna
you.
forget
If
the
you get
square number.
254 meters.
Oh, no. Oh, yeah, don't act like, oh, Mr. Burkhead, we would never give you an answer that doesn't make any sense.
Bro, I got 20,000 meters per second literally earlier.
Yes.
On this assignment.
Yeah.
This assignment.
Yes, just today.
I promise I won't forget the square root, but I will forget to square a number.
Okay.
I will forget to make sure that my answer
So,
makes sense.
my UG was what, 12.7? So somebody take 12.7 times 2 divided by 0.1 kilograms, and then take the square root.
15.9.
What'd you get?
15.9.
Yeah.
Seem reasonable?
Yeah, that makes
Yes.
sense.
Less than 25, we're at 19. Okay, cool. Nice. Okay. Now, one last problem.
It's very simple.
So, we'll go back to the 2 meter high tennis ball, okay? And now, instead of just dropping it, I'm gonna throw it up in the air
And
and
let it
then let
fall.
it fall.
Cringe.
Why?
Because now we have to do
What
more math.
changes?
There's height,
Oh, there's height and
It's
more
gonna
height.
like turn around and then fall. And
okay.
It starts
We have
off.
to do more
Drop
math.
It starts off with kinetic and potential
Oh! It starts off with kinetic energy.
And potential.
energy. And potential.
So, at the top, you're still going to have UG, but what else are you going to have?
Kinetic.
Kinetic.
Kinetic energy. Now, at the bottom, that's going to equal UG prime plus KT prime. True? Mm-hmm. But when it lands, what's going to happen to my value of UG prime?
0.
It's going to be 0. So, if you look at the velocity that it had when it was just dropped of 6.26, if I throw it up in the air, is the velocity when it lands going to be bigger or smaller than 6.26 meters per second, gap shot?
Say yes.
Yeah. Say yes. Say yes. Say yes.
It'll be greater.
Yes.
You say that with no confidence.
Greater.
Oh, great, you phoned a friend. Great. Why?
I can't answer that.
Yeah, Sean, I throw it up in the air. What does it have? And, so does it start with more energy?
No, it's
Yes, it starts with more energy.
Yes.
It starts with more energy, therefore when it lands it's going to have,
more
so therefore it's going to be going
faster.
this. Not that difficult.
Energy plus energy equals more energy, Gapshot.
Yes. But not if you take the square root and divide by pi. And then take the integral of it. Okay,
Do it in your calculator.
so now we're just going to do a variable game. We're not going to put in any numbers.
I like variable games. I mess it up all the time.
I know.
I don't
This is
like
why we
variables.
do this. So what do you need to calculate the
Height and mass.
in GH?
G8.
Right?
Oh,
What do you need to get kinetic energy?
In V squared.
1/2 mv squared.
1/2 m
V squared.
V
v
squared.
naught squared, right?
Oh,
Yeah, v naught squared.
that's important.
yes.
That is important.
Okay.
Very important number.
Now, what do I need to calculate my final kinetic energy?
Oh, 1
1/2 m
v squared.
v squared?
Oh, it's final, yeah.
Final?
Final.
Wow.
Yep.
Wow. So, what can I drop out of the equation?
Mass.
Now, you all know my feelings towards fractions. At this point, what can I do?
You gotta be, you get that equation.
Oh!
Get that
Oh!
Hold on, give me a second.
Wait, no, look.
Wait for
because,
it.
bro. Okay.
do you see it?
2gh, right? Plus v naught squared equals,
Ah.
oh, you get that equation. So what's the basis of that equation? Energy. Okay, that's why when I gave you that equation, I said at some point, I'm going to show you where this equation comes from. This is that moment.
We just did like an hour and 15-minute long lecture on how that equation exists. And I
Well, that
like
really wasn't the whole point of the story, it's just the end of the story. Now, interesting concept though. So, I take the ball 2 meters and I throw it up in the air, it's gonna land with a certain velocity. True?
Sure.
True?
It better be moving.
Now, if I
Weird
throw
it's
it
not.
down with that same velocity from a height of 2 meters, is it gonna land with the same velocity as if I threw it up in the air?
Yes. Yes.
Why?
Because if you throw it up at that velocity, once it turns around and comes back down, it'll be moving at the
You're
same
making
velocity
it
coming down.
complicated.
Oh, it's
The energy's the same.
Same amount of energy. Same amount of
Is
energy.
kinetic energy a scalar quantity or a vector quantity?
Scalar. Same amount of energy. So boom.
So the direction that I throw the ball
Does not matter.
is a part of the story. What, Cap Sean? Okay? Direction that I throw it. I could throw it down. I could throw it up. Guess what? I could throw it at a 45-degree angle. Guess what? When it lands, it's still going to have the same amount of
Kinetic.
kinetic energy. And kinetic energy is a scalar quantity.
What?
I threw it back.
Danny?
Okay.
Oh, God. Okay. So, here's the point of the story. As you go through these problems, keep in mind that the only thing you can do is transform energy. Yes. Now, back to the bounce. When I drop it, does it bounce to a height of 2 meters?
No.
No, we lose some energy. The particles in here are vibrating a little bit. Okay? You heard some sound. Okay? You lost some energy in the collision. Now, if it was a perfectly ideal collision, how high would it bounce back up to?
2 meters.
2 meters.
Good job,
Okay.
Colin.
All
I
right.
apologize for my work on 18.
So stop yonder camera.